This conference will now be recorded.
Yeah, I sent an email to Durga's or people. I don't have your number, so only I sent an email to them, but they forgot to inform you.
He did not intimate anything to me.
Yeah,
Okay, so tomorrow
because
I'm taking class from 5 to 7:30. You are ready, right?
5 to 7:30. Okay,
Evening, 5 to 6
evening.
and half an hour break. 6 to 5 to 6 continuous and
Huh.
5 to 6. Okay, let us otherwise 5:30, 5 to 6.
Yeah, no problem. I will be available, but I would like to confirm few things because now we are taking you are taking Python actually. So next thing, what you are planning to do actually? What are the things we are planning to teach?
Yeah, actually within 3-4 classes our course is completed.
Yeah, that's what I'm wondering actually. Python once over, so after Python, we need to that AWS Boto 3 and Azure packages and all that also will be
No, no,
covering, right?
Azure packages are not covered with Python. Already we have covered Azure with Terraform, right? In the beginning
Yeah,
only we
that
told.
that yeah, that is AR template we completed, but
Boto 3 for AWS. Okay, just I will
yeah,
show
yeah, that
how
I
to create
know.
resources in AWS. We don't create any resources in Azure by using Python. Okay,
Okay.
already we have discussed many examples in Azure with Terraform. Many.
Oh yeah, yes, Terraform we did, but I want to know anything we need to specifically focus on the coding part using Python. Using AR template, yes, correct. We see, but anything, any small like Boto 3, any packages we need to add it and import it, and then make use of Azure services. I mean Azure resources could be good
I will give
actually.
links. I will give links, but practically I don't implement. Our major focus is Terraform and AWS only. Okay, Python is in our industries also. Most of the people are using Terraform, not Python,
Oh, okay,
because
okay,
with Terraform we have so many facilities. Okay, so many
okay.
facilities are there. We can do a lot with. We can do wonders with Terraform. But whatever activities
Oh,
we,
okay.
we are doing with Terraform, we cannot do with Python.
Oh, okay, okay. Fine. Okay, sir. Fine. You can carry on, sir. We'll complete. Yeah.
Okay, so in last class we have discussed about the static variables of a class. Today we are going to focus on non-static variables. Non-static variables and
Uh,
local variables. So the variables which are declared when a class, okay, not declared within the class, within the class by using self are known as non-static variables. So in the previous class, we have seen how to create static variable. Static variable is a common variable which can be accessed by every object of a class, and that is common for every object. And the memory allocation for static variable is done at class creation time. And if you want to declare a variable that can be used commonly, okay, better you declare that as a static variable. And a static variable is common, and for every object, so that is common. So I practical also have shown you. Suppose 3 employees are there. For every employee, there are some properties like employee number, e-name. These are different for different objects. But if you consider total salary or employee name is a common. to every employee. So that can be declared as a static variable. That can be declared as a static variable. So for static variable, memory allocation is done at class creation time. And when it comes to non-static variables, so these are declared within the class by using self, are called as non-static variables. The data which is separate, for every object, okay, is recommended to represent as non-static variables. Non-static variables. Non-static variables of a class. Non-static variables. For non-static variables of a class, memory allocation is done at object creation time. Object creation time. Non-static variables. Non-static variables of a class we can access within the same class by using self. Within the class, if you want to access a non-static variable, okay, you have to use self. Self is exactly like this pointer in Java. Okay, when you want to represent current object, then you need to write it with self. Non-static variables of a class, okay, can be accessed outside of the class, by using reference variable. Reference variable is nothing but object. Let us take one example here. Example, class x. Here I am giving some values here. Class x, define one method. Define m1. Self is mandatory. Every method will take self. Self dot a equal to 1000 and self dot b equal to 2000. And I am going to define one more method. This is for printing. And print self dot a and print self dot, and I am defining objects. After defining a class, I am defining objects. So let us say the object is x1. X1 equal to x. So x1 equal to x means the reference of x will be stored in x1, and using x1 I am accessing m1 and x1 dot m2. And print x1 dot a. Okay, so this is outside of the object, right? Outside of the class, if you want to access a non-static variable, we have to use reference variable. X1 is the reference variable here. And print x1 dot b. And let us create one more object here, x2 equal to x, and here x2 dot m1, x2 dot m2. Now let us run this program. Now two objects will have same values here, 1000, 2000. Let us launch PyCharm. Let us print it. 1000, 2000, 1000, 2000, 1000, 2000. This is a usage of non-static variables. Now let us let us do one more program. Okay, so let us write a few points about this one. Whenever we define non-static variables within the methods, those non-static variables will be added to the object whenever we call that method. So whenever we define a non-static variable within methods, so those non-static variables will be added to the object whenever we call that method. Okay, we have to call the method. Then only the variable non-static variables will be added. Okay, to that particular object. Just a minute. Hello.
Okay, sir. Define a non-static variable within the method. Those non-static variable will be added to those objects whenever we call that method. Okay, fine.
Okay. So let us write one program here. Class X define m1 self. Here I am defining self dot a equal to 1000 and same self dot b equal to 2000, and also define one more method. Define m2 self print self dot a and print self dot b. So here create different objects here. So how many objects we are going to create? So let us create two objects. Okay, like in last program we created. So let us see what happens here. We have to observe one thing here. So what are the things we have to observe? Let us x1 equal to x1 is a reference variable for class x, and x1 dot m1 method will be called. So when m1 method is called, what happens here? Self dot ab will be created for x1 object. X1 will be having a and b, and next. So we are hello.
Yes, yes. I'm looking. Yeah.
X2 equal to x x2 dot
M1 of. No, M2, M1 of should create, right? Because you should
Mm-hmm.
not create. No, M1 you should call M1 off, right? Then only the value should be assigned, right?
Two
X2 dot
dot.
M1 off, M1 off,
That's what
M1
I'm.
off.
That's what I wanted to show you.
Oh, okay, okay.
What is the error we are going to see? That one I wanted to show you.
Oh, okay.
So we are not calling M1, right? Are you seeing error here? X2 is not defined. Did you mean X something like that? First of all, we have to call M1 method. Okay, when you call M1 for M2 X2 object, then only we are calling X2 dot M1. So when I call X2 dot M1, there is no X2 dot M1 here. X2 equal to X only, and there is no this object. Now let us see. What is that error here? Name error. Name X2 is not defined. So why it is saying that X2 is not defined here?
And
So
in line
clearly you
number
are
12
selling
itself,
me,
we declared. No, no, in line number 12 itself, you 13 itself you declared. Can you remove it? 13, sir.
which one?
13, line
This
number
one?
13. Yeah, 13. That itself wrong. Yeah, now it's fine. Now can you execute it, sir? See,
Attribute
X1
error.
is called, yes, attributed. Because X1, X2 is
Because
not
X
called
object
the
has
amount
no
of function.
attribute A. Yeah.
Yes,
We did not initialize A, B values for X2 object, right?
yes, yes, correct, sir. So we need to call them. Yeah.
Yes. So that is why this error has come. That is why I have shown
Mm,
here.
mm, mm,
Now, suppose here we have classes and objects,
mm,
and object is completely it is a implementation of class. Suppose I have created one class with a few attributes like name, employee number, salary, and I have 10 employees in my organization. Every employee will have its own employee number, salary, and designation. And every time when I want to initialize object, should I need to call functions? But calling a function every time when you want to assign the data, it is very difficult task. Okay, in case of one or two employees, you can call methods. Okay, by using methods, the data is initialized for that particular object. But when objects are more, 100 objects, 200 objects are there. Okay, calling methods for 100 objects is very difficult. So for that, so in Python we have a concept called constructor. So what is a constructor actually? Constructor is a special member function which gets executed when you create an object. When you
yes.
create an object. So what is the difference between constructor and method here? Method must be called explicitly, but whereas constructor is called implicitly. You need not to call constructor. Automatically it is going to be called when you create an object. Okay, so your constructor is a special member function which gets executed automatically when object is created. Let me write the definition. Constructor is a constructor is a special member function which gets executed when an object of a class is created. So in Python, constructor should be double underscores and write in it once again double underscore and write self. But in other languages like C++, .NET, Java, constructor name must be same as class name. But in Python, okay, so your constructor general format will be like this. So it will start with two hyphen symbols in it and followed by these two hyphens and self. This is a general form of using constructor. Okay. And what are the differences between constructors and methods? So the job of
Called simplicity.
constructor is to initialize members of a class,
Yes.
and the job of function is to write some business logic. It is not
Yes.
for initializing data
The
members.
variables.
It
Yes.
is
Data
especially
members.
writing business logic.
Yes. Correct.
And constructor is called automatically, whereas method must be called explicitly.
Okay.
Explicitly. Methods are used to represent business logic to perform some logic, some calculations. So constructors are used to initialize data members. Okay, these are the differences between constructors and methods. And method name can be any name, but constructor must like this. Constructor must be defined like this only.
Like this underscore underscore init underscore offset.
Yes.
Okay.
Let us do one exercise, one program.
Okay.
Class
Mm.
X define two underscore symbols
Mm.
init and again two underscore symbols self int slash n constructor of class X. Just I'm printing a message. Define m1 self is print m1 of class X. This is a method definition. So your method name definition, method name I have given m1, and whereas constructor so was started with the two underscore symbols. And let us create one object here, x1 equal to x, and x1 dot m1. Let us create one more object here, x2 equal to x. This is the other reference, and x2 dot m1 and x2 dot m1. Okay, only one time. Now let us write this, let us execute this simple program. I am
No,
not
we
calling
need to.
constructor here, just I am calling m1 only.
No, no, you're calling constructor only because when you're creating an object, it should call by default, right?
Yeah, it should be called internally.
Internally. And the print statement, you need to give double quotes so that you can take care of it. At the end, line number 3. Yes. Ah, yeah.
x2 dot
What
m2.
happened? M2, no, we need to delete it.
M2 is not
Uh,
there, right?
yeah, it's not there. So
This is
from
m1
line number
only.
10, from line number 10, from line number 10, you need to delete.
x2 dot m1.
No, from line number 10, it comes from previous code. So we should supposed to delete it. Line number 10 to 14.
Line number 10 to 14.
Yes, yes. Now it will work. Yeah. See,
Right.
now it's working.
Now this is constructor part. Now this
Yes.
is method part. And
The
again this
part,
is
this is
constructor part. And
constructor part, and again it's a method part. So constructor
method
is
part.
calling by default, but the constructor here we need to give underscore unit. That's the only catch.
Yes, exactly. That is a general form.
Okay. In Java, we used to give the exact function name itself, the object name itself as
Exact
like a
class
function,
name.
and then
Exact class name you have to give.
give. So here it's underscore
So
underscore unit.
exact
Okay.
class name, constructor name must be same as class name. That is a rule in
Oh,
C++ also. In
Java.
C++, Java also, the constructor name must be same as the class name.
This name. Okay.
And let us write one more program. Example 2. Class X define underscore underscore init underscore underscore self dot a equal to a. Here I am, this constructor will take two arguments here. These are x comma y. Two arguments it is going to take. Self dot a equal to x
Uh, uh,
and self dot b equal to y.
no, self dot a. Okay, fine, fine, correct, correct, correct.
Define display
Display of print of
info.
self dot a.
Print self dot
Self
a
dot a, and again print
and
self dot
print
b.
self dot b.
Mm. X1 is equal to x of
Define
something.
modify. I'm
Modify.
modifying variables.
Yeah, sure.
Self dot a
That a
equal to
is equal to
self dot
self dot b.
a plus I'm
A
adding some
plus one,
value
some thousand. Okay, okay.
1000. B equal to self dot b plus 2000.
2000.
And this constructor is taking arguments, right? We have to pass two arguments. X1 equal to x of I am giving 1000 comma 2000. 1000 will be stored as x and 2000 will be stored as y.
Y
X1 dot display
display of and x1 dot
and
modify
x1
of
dot I am modifying the values. Since I want to modify the values, I am calling modify function.
modify of so 1000 2000
And after
and
modifying,
2000
once again I am
3
displaying.
2000 4000. Yeah.
And I am also creating one more object here. X2 equal to x of 3000 and 4000.
4000
And x2 dot display
x2 dot display of
and x2 dot
x2 dot
modify
modify of x2 dot display of
x2 dot display.
display of
Here two objects will be having two different values.
yes
X1 will be created with 1000, 2000 and
2000
x2 will be created with 3000,
3000
4000.
4000. Yeah.
Let us run this.
Good. Fine.
This is the result. Okay, yeah, this is how we can use constructors. So next we have to discuss one more category of variables. This is local variables.
Mm, mm.
So local variables are the variables which are defined, okay,
Within
within
the
the method
function.
only. The scope of a local variable is within the method,
Yes.
and we cannot access them outside of the method. The variables which are declared
Mm,
within the method definition
mm,
or
mm,
method
mm.
body are called
Local variables.
local variables. The data which is required to use within particular
Method
method, particular method is recommended
is
to
recommended. So the local variable.
represent as a local variable.
Yes.
So here the scope of local variable is very small. So within the method only they can be accessed. And one more point for local variables. For local variables of a
Mm.
of a method,
Mm, mm.
memory will be allocated whenever whenever we make a
Okay,
method call.
whenever we make that call.
Local variables
Mm.
of a method cannot be accessed outside of a method. Very simple example I can write here. Class X define M1. Now it is going to take self as argument. So I am defining a variable called A is equal to 1000. It is a local variable. Print A, define M2, self equal to some 2000 and print B.
Print of v. Yeah.
Now let us create objects. X1 equal
Yes.
to X,
X1 is equal to x of
X1
x
dot,
dot m1 of
I'm calling M1. I'm calling
m1 of
M1 means A will be created here.
yes.
X1
X
dot
dot
M2
m2 of b will be created here.
will be created. X1 dot M2.
M2 of
And
yeah.
when I say X1 dot M1, what happens?
X1 dot m1 of a will be created.
A will be
Actually,
created.
assigning the same yeah a will be created and assigning 1000 to a. Yeah.
Let us remove it. Why this is not required?
Yes. Yes.
1000, 2000. This is about local variables. So here totally we have
Mm.
discussed three types of variables: static, non-static, and local
Local
variables.
variables.
And today we have finished constructors. Okay, and
Yes.
the
Correct.
differences
Yes.
between constructors and methods also we have discussed. Okay, just a minute.
Yes. Okay, sir.
Okay, now we have discussed the constructor. And what is destructor here?
Deallocation of memory or deallocation.
Reallocation of memory. Okay,
Okay.
destructor is one special method, and the destructor name should be underscore underscore L. This one. So that is a notation how we can write a destructor here. So let us write one small program, small application, so that it will be very clear. Let us write one example. Destructor will be executed automatically whenever object is deleted from memory location. Now let us define a class X. I'm defining a constructor first. Define one space init two underscores self. This is constructor part. And print constructor of X.
Mm.
Define. I'm defining a method self. Print m1 of X. And I'm defining a constructor, sorry, destructor, two underscores del, again two underscores self. Print destructor of X. Now let us create objects for this. X1 equal to X, print X1. The address of X1 is printed. X1 dot M1 and X1 equal to X and print X. X1 dot M1. What is going to be printed here? Can we expect?
X1 dot m1 of should be print m1 of x.
So let us see practically see it. Copy this.
Actually, should they first print the constructor and then print the other part,
Destructor.
function part. Yeah. What is the
Constructor is
m1 of
executed once. And
yes
next see constructor of X. I print X1
x
means
m
this is address of X1.
m1 of x, the constructor of x. Okay, good.
Next X1 of M1.
M1 of
Method is
M1
printed.
of means yes, method is printed in the constructor also. No,
Next X1 equal to X. And
yeah,
once again
okay.
constructor part is printed. And next destructor. Next destructor. Next constructor. Is it clear?
The last one x1 is equal to x of so
X1 equal to
x of it
X1.
that yeah, creating an object. What is the so x1 dot m1 of
This is
m1
print
of
X1. Print X, sorry,
yeah
print X1 this is.
yeah x1 okay.
Yeah, two times the addresses are different, right?
Yes,
This is
address
the
are
address
different.
of object for first time. And this is the address of for second time.
Second time.
So two times X1
Yep.
is created here. So two times memory is allocated.
Okay.
And every time when object is destroyed, okay, automatically, okay, deallocation is done at the deallocation time, automatically the destructor part was executed. Is it correct or
I
not?
mean, no, this is correct. But 1 minute, sir. You're printing x1. So okay, x1. So
See, here first I am explaining. First,
no, sir.
what
But
happens? X1 equal to X. Here, the first
yeah,
assignment. Here.
it will create a constructor and then print a object variable. Correct.
Yeah,
Second thing is
yeah,
yeah,
object.
and second variable. And another thing is m1 of x means print the m1 method function and followed by uh, y
Followed by
oh
destructor.
no, followed by
Followed by
destructor.
destructor.
No,
Yes.
or yes, destructor.
Because
So
your object is destroyed, right? When object is destroyed, deleted, automatically the destructor part is executed.
oh, object is calling deletion part calling by default.
Yes.
Okay.
Destructor part is
But
called automatically.
Yes, only at the end of the statement, correct?
No, no.
Oh, okay.
Two times it is called, right? See, district of A.
Okay. Okay, sir.
Two
Fine.
times.
Okay, okay, okay. Okay, fine.
Two times it is called, not one time.
So whenever you're
Are you
calling that
seeing two
method,
times
it
here?
will,
First
it
time
will,
and second time.
yes, calling and deleting. Okay. The deallocation of which memory it is doing actually?
Mm-hmm.
Whenever you're calling m1 of method and this destruction part calling automatically, right? So the deletion, I mean destructor calling automatically whenever you call one method m1 of method. Similarly,
Yes.
second time also you're calling m1 of method, destructor call automatically.
Yes.
So
Yes.
it's, but so underscore del underscore you mentioned next to the single function. What happen if two function have been written, and can you show me where it, can you write one more function m2 and show me, sir? Let's see, m2
Okay, you're
function.
asking me to write here.
Yeah,
Here the
because
M2 is also called. When you write M2, M2 is also called.
no, I want to see whether two function can provide two destructors. Should print two destructors. That's my
No, no,
only answer.
two destructors, how it is going to print? Only one time destructor is going to be called, right? Every
Ah,
time
yes.
when an object is being deleted, destructor is called.
Okay, okay, okay. So one time only. Okay, okay, sir.
Yeah,
Whatever the function you
one time
return,
only it is going to
when
be called, not two time. Once for every object. So here, after calling x1.m1, see, destructor is called here. See, here this
okay,
is
okay,
destructor
okay,
calling, right?
okay, sir.
This is
Understood.
constructor calling. So
And
constructor
this is
of x,
destructor calling.
destructor part is called here.
Destructor.
Destructor, destructor.
Okay, 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 sir. Fine. When we use this destructor, sir, actually, I want to know in
Generally,
real time.
so when you want to deallocate connection, suppose I have established connection with the database server, and at the end of object destroy, okay, at the end of the program, I want to nullify the connection. I want to close the connection. So for that, you
Oh,
can write a
okay,
code, right?
okay, 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 sir.
So our next topic will be inheritance. Actually, inheritance is supported by Python also.
Mm.
And before that, let me write something using properties of one class into another class. You can use the properties of one class into another class in two ways. They are, one is has a relationship. Here I can write has a relationship. Next one is a relationship. So here we will come to know that what is a has a relationship and what is a relationship. Has a relationship on the concept of using the properties of one class into another class by using class name or by using reference variable. Reference variable name is known as a relationship. Now let us see on one program so that it will be very clear. So is a relationship is completely different from as a relationship. So here how inheritance is going to work. So what is whether type 1 is inheritance or type 2 is relationship. Okay, inheritance we'll discuss. Now let us see a small program so that it will be very clear. And first I'm defining class A, class X, sorry, class X. So after that, I'm defining a variable called a equal to 1000 and I'm defining a constructor here. Init self. Here self dot b equal to 2000. A is a static variable and b is a non-static variable. Okay, because a is defined outside of all methods. Define m1 self, print m1 of x, and I'm also defining one more class, class y, and class y. Okay, we'll be using the properties of class x. So if class y wanted to access members of class x, okay, class y has to create a reference variable object for class x. So this is nothing but has the relationship. That means class y has class x. Class y has class x. This is just like wall has clock and wall has mounted, wall has picture. That is like that. So here wall is that is a major class, and whatever things we are seeing on the wall, okay, that is has a relationship. Okay, wall has clock here, so you can consider here wall as x and clock as y. Now within class y we are going to use class x. So if you want to utilize the members of class x, okay, within class y we have to define reference variable object for class x. Okay, so how that is going to work, let us see. So here class y, let us see c equal to 3000. I am defining one more static variable here. Define here, I am defining a constructor init and self. Then I am writing something like self dot d equal to 4000, and I'm also defining one more method like define m2 already, because m1 is defined in class a, class x, so that is why I am defining method 2 m2, and I am printing a message print m1, sorry, m2 of x, and also define one more method, define m3 self, and say print m3 of x, and here print x dot a. Okay, so what is x dot a? Actually x is a class name. Since a is a static variable, using class name we can access a because it is static variable, and I am defining a variable. I am defining an object for class x here, x1 equal to x, and print I am defining like x1 dot b. So x1 dot b means b value from class x will be printed here, and x1 dot m1 method from class x will be called x1 dot m1. Okay, now print y dot c. Okay, y is c is a static variable, so directly by using class name, okay, it can be called y dot c, and print self dot d. Okay, your D is a non-static variable. Where it is defined here? In a constructor. In the constructor, D is defined. And here, self dot M2. What is this self dot M2? Where M2 is defined here? Within class Y. And print M3 of Y. Now let us do object creation. Y1 equal to Y. And Y1 dot M3. Now let us see what happens here. First, we are defining class X, and within that we have defined a static variable called A. And after that, I am defining a non-static variable called B. Self dot B equal to 2000. And in class X, we are also defining one method called M1, and M1 of X will be printed. In class Y, we are defining a static variable again. C equal to 3000. C equal to 3000. And we are also defining one constructor where I am defining a non-static variable called D equal to 4000. And in class Y, I am also defining M2. In the M2, this is a message to be printed. And in M3, okay, M3 of X dot A. Okay, X dot A means here A is defined, right? By using class name, we are accessing this one, X dot A. And we are creating object to access the members from class X. We are defining an object here, X1 equal to X. And X1 dot B means here this will be called 2000 is printed here. X1 dot M1, here this method is called. Print Y dot C. So Y dot C is a static variable. Using class name, we are printing that. And self dot A means we are printing this value. And self dot M2, and in within that we are printing the some message M3 of Y. So this is nothing but what? Has a relationship. Okay. So we have two classes here, class X and class Y. Class Y has a class X. Class Y has a class X.
Sir, you need to extend right from Y to X.
No, extension is different. That's why this is first one. This is has a
Okay,
relationship.
okay.
In is a
Okay, sir.
relationship, we are going to extend it.
Okay, sir.
This is Python. Or in case of Java, we are going to write extends. But it is Python,
Yes,
right?
yes.
In Python, this is has a relationship.
Okay.
Okay, how to extend that I am going to show. Don't worry about that. Okay, I will show that.
Mm. Mm.
So first of all, is it clear? Is there any confusion?
No, sir. Can you in the down? You are creating an Y object. No, no. The down last. Yeah. Creating a
Hmm.
Y object and calling the M3 function. And the
Yes.
inside M3
Within
function only
M3
you
only
are.
all the things are done, right?
Uh,
Within M3 only all
yes.
the things are done.
M3 only you are declaring everything. For creating a X
Yeah.
function. I mean a X object and then assign to X1 and X1 dot M1 of. Okay, okay.
Yes.
Within M3 only you are doing everything. Okay, sir.
This is about has the relationship. So next, when it
Okay.
comes to is a relation, okay, this is known as inheritance. Is a relationship. This is also known as or inheritance. The concept of using the properties of one class into another class directly is known as a inheritance
Inheritance.
or is a relationship.
It's a relationship.
A class which is extended by another class is called a super class or base class. Base class. In a class which is extending another class. Another class is called subclass or derived class. Derived class only. Superclass properties directly we can access into the subclass like as a subclass members. Okay, so this is a relationship. Okay, so the types of inheritance mechanisms are there. Okay, we'll discuss one by one. First, let us define one class here, class X, and I'm defining a variable called a equal to 1000 and define m1, say self, print m1 of X, class Y. Okay, at the time of creating class Y, you can tell that it is created from class X. So within the brackets, you have to mention super class name or base class name, and it is clearly telling that class Y is a class Y is creating from class X. So it can utilize what are the properties that are available in X. And here I am defining a variable, another variable c equal to 3000, and I am defining a constructor also here. Init self dot d equal to 4000. And I will define one more method here. Define m2 self print m2 of y. M2 of y. And I'm also defining one more variable, one more function m3. M3 will also have self int y dot a self dot m1 self dot m1 print y dot c int self dot e and self dot m2 and print m3 of. I'm defining an object y1 equal to y y1 dot m3. So which is being called here m3 function. So what m3 function contains here? First print y dot a.
Yeah, it
Y
should
dot
print
a means
1000.
1000. Print y dot a. Y dot a means it is going to print
1000 and m1 of m1 of
is
means it will be m1 of
y dot
x
x or y dot a. Just a minute.
and y.
Class లో ఉన్నాను నేను. Okay, so your y dot a means since y is extending from class x, okay, directly
Yes,
it can print the values of x. Y
1000
dot a means it can
x
print. Self dot
okay.
m1. Self dot m1 means
m1 of x
m1 is going
m1
to be
of
printed.
x
Y dot c. So y dot c means a static variable. Static
3000
variable is printed. Self dot d.
3000
Since it is non-static variable, we are printing this d value by using self.
d value
And self
10
dot m2 means m2 will be printed. And finally, we are creating an object y1 equal to y1 dot m3.
103
Printed, right?
mm.
Okay, so tomorrow we are going to see types of inheritance mechanism. So how many types of inheritance mechanisms are supported by Python? That we are going to discuss. If time permits, I will also start polymorphism. Okay.
Okay sir, fine.
Tomorrow at what time? 5 or 5:30?
Okay,
In
make it
between
as 5:30 sir, 5:30 to 7:30 you
7:30.
told, right sir?
Not 5:30,
Okay sir.
5:30 to 8. In between we have half an hour break, 30 minutes break. Okay.
Okay sir, okay fine, yeah.
5:30 to 6:30 and 6:30 to
mm.
7 is break.
Mm.
Next one, next again 7 to 8.
Okay sir.
Did you get my point? So 5:30 to 6:30, 1 hour. 6:30 to 7 break and 7 to 8,
Sir, sir, if
one
you
more
don't
hour.
mind, we can, sir, we can, I can 5:30 to 6:30 and 7 to 8. Okay,
6:30 to 7 break.
okay, sir, fine. Okay,
Hmm.
sir, fine, sir. Yeah, thank you, sir.
Okay. So I'm stopping the
Yeah.
meeting. Tomorrow meet again.